Hello again, and let's do tangency problems, and we are done with one. We have three types of tangency problems here. First is the tangent line for the graph of a function. Basically what we want is this kind of form, y equals to m slope x minus x0 plus y0, this kind of form. And x0 is typically given, and y0 you simply plug in the number into the function, and then you can find out. And then the slope, and that's the most important part. That's the hard part. We have to take the derivative and plug in x equals to x0. Now, the derivative function is not a slope. You have to plug in and get m value. Okay? All right. Now, let's go to the implicit curve. Similar kind of problem, but here in this case, x0, y0 explicitly given. So x0 is -1, so you have so x1 is -1, so that part, and then y1 is that. Okay, that part is explicitly given. Negative of -1, so we have +1. And then that's something we have to find out from the derivative. How do I find out from the derivative? Well, here's the equation, and you have to take the derivative implicitly and plug in those values. Ready? Okay, let's go ahead with the implicit differentiation. All right, let's do the left-hand side. We have something complicated, and then to the third power, so I hope everybody can clearly see that this is a chain rule. 3 comes out, and then whatever the inside, subtracting 1 from the power, and that's not all. We need the derivative of the inside. That should be the structure of the left-hand side if you take the derivative. Is everybody happy with this? The use of chain rule. Let's go to the right-hand side. Right-hand side, we have a product of two functions, x times y squared. So u prime v plus u v prime. That's going to be the structure here. Okay, ready to fill in all those. Okay, let's go to left-hand side again. You see, it's a chain rule, so inside never changes. So step 1 of the chain rule, outside function, derivative of outside. Step 2, nothing changes inside. And step 3 is the derivative of the inside. Don't take the derivative and put it here. It's just copying, pasting. Here is the derivative computation. Ready? Okay. What's the derivative of x cubed? 3x squared. Is everybody happy with that? Now, what's the derivative of minus 2x? Just minus 2? Okay, good. And what's the derivative of minus 2y squared? Minus 4y. Is that all? I mean, 2 comes out, so minus 4y, but that's not it. Actually, it is correct. It's just that it's not complete yet. Times y prime. The derivative of the inside pops out because of the chain rule. And this one I'm highlighting in red because that's going to be my slope. Whenever you take the derivative with respect to y, we have y prime. Now, if you prefer to use dy over dx, that's fine. Please go ahead and use it. My preference is y prime, which is a little bit simpler, but if you use dy over dx here, that's perfectly fine with me as well. Our textbook author prefers to use dy over dx there. Now let's see, how about the right-hand side? we were doing product rule. So okay, the derivative of the first function, derivative of x is 1, and then y squared, and then x, and the derivative of y squared, so we have 2y, and then we have y prime. Again, I'm highlighting this y prime with color red because this is going to be the slope. So whenever I use the derivative rule to y, you need this y prime, and that is the quantity we are looking for. All right, ready to plug in the numbers. Okay, all right, let's plug in the numbers. X is -1. And y is 1. And then y prime is gonna be m. All right, and this is gonna be 1, and that's -1, and that's 1, and y prime is equal to m, the slope. And here in this equation, we are looking for m, and well, this is just a elementary computation that you'll have to do with well, paper, pencil, or calculator. It doesn't matter which one you use. In any case, the point I'm trying to make here is this is an elementary computation, just numerical computation. So this is -1 cubed, so -1 and minus plus, so +2, and then -2. So these two cancel out. -1, total thing squared, so the whole thing is 1, and times 3. So this is just 3 times, and then this is -1 squared, so it's positive. 3 minus 2, so 1 minus 4m, and then how about the right hand side? 1 times 1, and then minus 1 times 2m, so minus 2m. And this is an elementary computation. 3 minus 12m is equal to 1 minus 2m. So flip m to the right hand side, we are going to get 2 equals to 10m. M is going to be 1/5. I hope my computation is correct. Please check. And then the final answer, of course, should be the slope point equation, this form. So it's going to be y equals 1/5 x minus plus. And this should be the final answer. This is a slope, and then the point. Did I do this right? Yeah, it's correct. Okay, 1/5 is correct. And then there's even the picture. And here, this kind of figure like a heart. That's the implicit curve. And then the slope is 1/5 at -1 comma +1 right here. So there are 3 types of tangency problems. We did graph problem earlier, and we just did a second type, implicit curve problem. As for the students' performance this particular year, it was okay. As a matter of fact, few students got wrong here in this problem. The derivative was easy, and the tangent line was also straightforward. For this problem, there were a horde of students who made some mistake, numerical computation mistake along the way, and then got incorrect answer. But I graded really generously on those kind of silly mistakes. After all, this is computation intensive. So for that, even with wrong answer, many students got perfect score. And if you're missing the derivative or something, in that case, a little bit heavier deduction. If you're missing y prime or dy dx, now that's a little bit bigger mistake, and so on and so forth. So there were all kind of spectrum of scores there, but generally it was okay, as a matter of fact. And moderate or moderate to hard, and definitely more than 2/3 of the students got it right, close to 3/4. Okay, let's go to the last problem here. This is parametric curve problem. And for this problem, let me give you a formula for parametrics here in this video, and then let's complete the problem in the next video. Here, let's just equals m x minus x0 plus y0 is the usual. Where x0, y0 is equal to x of t0, y of t0. Basically, you're plugging in t equals to pi over 2. To this function, you're going to get x0. And to that function, you're going to get y0. Let's see. Blue is x, y is red, and this is blue function, x function, and then this is red, y function. So x0, blue, is obtained by plugging in t equal to t0, and y0 here is obtained by plugging in t equal to t0, and that's it. And I'm going to run out of space, so let me go ahead here. M is equals to y prime of t0 over x prime of t0. I guess I can just complete here. And then let's choose the next color, let's say green. So we have to take the derivatives. Take the derivative of this blue and take the derivative of this red, and then you have to plug in t equals to pi over 12. But in the end, what we need is this slow formula, y prime of t naught over x prime of t naught. What kind of computation do you actually do here? We'll talk about it in the next video. Don't worry, we are going to start over.